All right, this video is on solving rational equations. And just to make sure we really understand what we're getting at here, if I was to say 1/5 plus x fifths equals 4/5, you would say, oh, that must be 3. And it's not because you're looking at the fifths, it's because you're looking at the top. 1 plus 3 is 4. So that's the idea that we use when we solve rational equations. We make sure we have a common denominator. And then after we have a common denominator, we can ignore it and we can just look at the top and figure out what would solve that equation. One thing we have to keep in mind when we're solving rational equations is we have to look for extraneous solutions. So extraneous solutions are solutions that you're going to find mathematically, but when you plug them back into the equation, they don't work. So solutions that don't work. That's not a formal math definition, that's a Miss Rice definition. And so for different types of equations, we have different types of extraneous solutions, but for rational equations specifically, these are going to be solutions that make the denominator equal 0. So if you guys remember back to the first unit we covered, we looked at different domains on specific functions, and one of those functions was rational functions, and we always said the denominator can't equal 0. So now with this unit, we're kind of referring back to that idea, and we're making sure that when we solve a rational equation, our solution does not make the denominator 0. So I have a few examples for us. For the first, we have 1 over 3m to the third minus 1 over 2m equals m plus 2 over 6m to the third. And first, I need to go ahead and figure out what my common denominator would be. I can see that I have a 3 and a 2, so I know that my common denominator needs both of those, which is 6. So with the numbers, as long as I have a 3 and a 2, 3 times 2, I know for sure that I can get that. And then this one has an m to the third, and this one has an m to the third, and so I need at least m to the third. That's just an m, so that's a little bit smaller. So it looks like my common denominator is 6m to the third, and then all of my pieces will be able to have that. So if I look at the first fraction, I need to multiply by 2 on the top and the bottom. For my second fraction, to make sure it has the 6m to the third, I've got the 2 already, so I need to multiply by 3 on the top and the bottom. To get the m to become an m cubed, I need an m squared on the top and the bottom. And then the third fraction already has it. So what I've got going here is I have 2 minus 3m squared equals m plus 2. And at this point, I can say, now I no longer need those denominators. This is kind of the point up here where I could cover this up and say 1 plus 3 is 4. Now I'm going to cover up the denominators and solve that equation. And because we are in pre-calculus, we're going to solve an equation that's not quite as easy as that first one. So I can see that this is a quadratic. If I want to factor this quadratic, I usually prefer for my squared term to be positive. And so I'm going to go ahead and add this to the other side. Remember, in a quadratic, we always make it equal 0. So if I add this and subtract the 2, then that makes it equal 0. Now, if you wanted to move everything to the left side, that would be fine. You could always use the quadratic formula if you didn't feel like factoring. So if we look at this problem, this is not a trinomial, it's just a binomial, so that means that I'm probably doing the GCF factoring method. So I'm going to take out an m, and my leftovers would be 3m plus 1. So I have two solutions. I have m equals 0 and m equals -1/3. And if I look back at the beginning equation, if I were to plug 0 into the bottom of the fraction, that would be a problem. I would get 1 over 0, and I would get 2 over 0, and then I would get 0 plus 2 over 0. And so this is considered to be an extraneous solution. It does not work. I found it mathematically, but it doesn't work. And then this would be the one solution for the equation. Now, the nice thing is you can actually check these answers. The graphs can look real crazy. I'm going to plug this in as a fraction. So I hit alpha y equals to be able to plug that in as a fraction. 1 over 3x to the third minus 1 over 2x. 1 over 2x. And that's going to equal x plus 2 over 6x to the third. So when you're checking the solution to an equation, you just go ahead and graph them. There's the first equation. Now, I can't see a whole lot of what's going on, but I am expecting the answer to be -1/3, and I just need to see where the two graphs cross. So if I do second trace and I do intersect, I'm just going to move to like -1/3-ish. And what you'll see is that they do cross at -1/3, even though I can't see it. My calculator was able to find it, so that is the solution. And if you plug in -1/3, then each side of the equation equals -7.5 when you plug it in. So that's one way to check your answer. There was no solution of 0. I could try to do the intersection method again, getting my x closer to 0. And if you look, actually, you can see that 0 is undefined. That's why we're not going to get a solution there. Okay, so here's for example number 2. I'm not going to go through that process of checking it every single time. I just wanted you guys to know that you could check it if you wanted to. All right, so for this one we have n plus 5 over 3n squared equals n minus 2 over 2n minus 1 over 6. And so if I look at this particular problem, I can see that my common denominator, again, needs to have a 6. That's not going to be every time, but because we have a 3 and a 2 and a 6. And then we need an n squared. So the first fraction is going to need to multiply by 2 on the top and the bottom. The second fraction is going to need to multiply by a 3n on the top and the bottom. And the third fraction is going to need to multiply by an n squared on the top and the bottom. So that leaves me with 2n plus 10 over 6n squared. And that is 3n squared minus 6n over 6n squared minus n squared over 6n squared. So at this point, I have all my denominators there, so I can go ahead and get rid of them. So I have 2n plus 10 equals 3n squared minus 6n minus n squared. So I have 2n squared minus 6n. So this right here, again, we have another quadratic. I can tell because I have an n squared. So I'm going to go ahead and minus the 2n over here and minus the 10. So that's a 0. So 0 equals 2n squared minus 8n minus 10. And this is a factoring problem. So when I look at this, I can see that I have a GCF of 2. And so to factor this, I'm looking for two numbers that multiply to -5, but add to -4. And so that would be -5 and 1. So n equals positive 5, n equals negative 1. And if I think about looking back at the original problem, if I was to plug those into the denominators, that would not be a problem. They wouldn't zero out. And so that means that both of these are good answers. Neither one is extraneous. Now, not every problem is going to be a quadratic. Some of them are just going to be one answer. But you will be getting some quadratics because this is not your first time covering this material. It's your second, and so we should be able to do slightly more difficult problems. Okay, here, we're going to do 5 over b squared minus b minus 6 equals 6 over b plus 2 minus 1 over b squared minus b minus 6. So here, to find our common denominator, we need to factor, and we can see already that these are the same. So we do need to factor these just to see what different factors we have in the denominator to make sure that we can get a common denominator. So to see what multiplies to negative 6 but adds to negative 1, I would have b minus 3 and b plus 2. And then over here saying b minus 3 and b plus 2. So that means that our common denominator is a b minus 3 and a b plus 2. And so that means that that middle fraction is going to need the b minus 3. Okay. So if I write out the entire problem now, I have 5 over b minus 3, b plus 2, equals 6b minus 18 over b minus 3, b plus 2, minus 1 over b minus 3, b plus 2. And so at this point, I have all of those denominators that are the same, and so now I can ignore them and just solve that equation. So I have 5 equals 6b minus 18 minus 1. And so I can go ahead and add that 19 over to the other side. And then I can divide the 6 over, and I get 4 equals b. And if I go back and double check, 4 minus 3 is not 0, 4 plus 2 is not 0, and so that right there is a good answer. All right, and we'll do one last example, and then I'll leave a few for class tomorrow. So here we're going to do b plus 3 over 3b plus 18. Plus 1/3 equals b plus 4 over 3. So here, just like before, I need to factor the denominator to see what the different factors are. So I can see the 3 and the 3. I'm definitely going to need that in my common denominator. And here I have a GCF of 3, and then that leaves me with b plus 6. So 3 times b plus 6 must be my common denominator. And so that means for this fraction, I've got the 3, but I need the b plus 6. And here I've got the 3, but I need the b plus 6. And I'm going to have to be careful right here. That's going to need to be FOILed. All right, so for the first term, I didn't need to change anything. All right, and then over here I have to be careful. So I have b times b is b squared plus 6b plus 4b plus 24. So all of my denominators are the same. That means I can ignore them now. Okay, so it looks like this is 2b plus 9 And we do have another quadratic, so I'm going to make it equal 0. I've got b squared, I'm minusing the 2 over here, and I'm minusing 9. Is that 15? So I'm looking for two things that multiply to positive 15 but add to positive 8. And that would be b plus 5 and b plus 3. And so my two solutions are -5 and -3. And I just want to double check that those are okay. -5 plus 6 is not 0. -3 plus 6 is not 0. So that means we're good.